So factor these. Looks like, yeah. Yeah. Okay, who is done? Who's still working? Who's not answering me? Lots of people, not lots of people. Okay, good. All right. Jaden. Huh? Jaden. So, what did you notice about these? Yeah, they all came out to be perfect squares, right? Okay. And they were all doable. I mean, it got a little bit funny when I was multiplying the 4 times the 9 and I get 36 and I had to pick a number that multiplied to 36, but added to 12. In general, it wasn't too bad. But there is a special way of recognizing a perfect square trinomial. And that should be on your next page that I put in the warm-up. Perfect square trinomials are in this form. The first term is a perfect square. The last term is a perfect square. If you take the a and the b and you multiply them and multiply them by 2, you get the middle term, plus or minus. Now let's go back and look at these warm-up questions and I'll show you what I mean. So I should be highly suspicious that it is a perfect square trinomial if I look and I see my first term is a perfect square and so is my last. In all of these cases, that's true. Perfect square, perfect square, perfect square, perfect square. Okay. So if you're suspicious that that could be the case, you ought to check. So this is how you would do that. Okay. So I would look and I go, well, the square root of 9x squared is 3x. The square root of 1 is 1. And now I've got to check that middle term. So to check it, I'm going to multiply them and then multiply by 2. And I go, okay, well, but if I multiply them, that's 3x. Multiply that by 2, that's 6x. And that matches the middle term. Okay. Once that's the case, you know that it's a perfect square trinomial. And the sign that goes in between here is the one that matches the middle term. So this is the 3x minus 1 squared. Okay. Same idea over here. What's the square root of x squared? Well, it's just x. The square root of 25 is 5. Multiply them together. And then multiply by 2. That's 10x. Joy. And my middle term is 10x. My sign here is the sign that goes in the middle. It's a perfect square. Okay. Now, using the AC method here wasn't so horrible. The numbers were quite small. However, look at those. It doesn't sound so fun to me to multiply 45 by 25. What do you get if you multiply 45 by 25, I guess? What?
49 by 24.
Yeah, 49 times 25. I'm gonna do that for me. Big number.
1,225.
1,000.
225.
Okay. I would have to think of numbers that multiply to 1,225, but add to -70. Does that sound so fun? No. But looking at this, I should be suspicious that it's a perfect square. My first term is perfect square, my last term is a perfect square. So let's check. That would be 7x and 5. Multiply them together. That's 35x. Multiplied by 2, that's 70x. Woo! So that's that squared. It makes it doable quickly. I mean, we can use the AC method here. It could be done, but it's going to take me a while. Same kind of thing happens here. I'd have to multiply 64 and 81 and then take a multiples of that product to add to 144. No, thank you. Okay. 64x squared is a perfect square. 81 is a perfect square. Multiply the 2. What do you get if you multiply 8 times 9? 72x. Multiply by 2. Yay. That makes sense? Uh-huh. This matches. If the middle term's minus, it's minus in the middle. If it's positive, it's positive in the middle. Okay. So how do you feel about that? Thumbs up, thumbs down, thumbs sideways? Okay. If I could think of a factoring, a special factoring problem that is neglected, it's this one. It's the perfect square trinomials. I don't want to neglect it. It shows up on standardized tests. It makes it fast and easy. Just because, and now I want to tell you one more thing. Just because it looks like it may be a perfect square trinomial doesn't mean that it is. So I could easily have a different middle term there. So I could have 4x squared, let's see, plus 9. Plus 15x. This is not a perfect square trinomial. It does factor. Okay, it will factor. But if you go through this and go, okay, maybe it's a perfect square trinomial. Well, that would be 2x, this would be 3. And then you multiply the 2x and the 3 and double it. Ooh, does it match? Ooh, no. Then it's not. Then you have to go with that AC method. Okay. Right. All right. So let me pull up your homework from last night. I can find it. I know I downloaded it. Where is it? File folder. No, hold on. Okay. You guys have questions on the assignment from last night? Ellie? Sure. So it says find the values of A and or B in each of the following equations. So what this is essentially asking is, what do I have to put here for A? Where's B? And B, so that this product equals that, right? So if you multiply out what's on the left, you distribute your 2x, then distribute your -1, that gets you here, right? The constant term here is your B. And if I combine my like terms, I know I have 2a minus 1x's, right? Well, 2a minus 1 has to be 5. Makes sense? So then I know a is 3. And if a is 3, I know that b is equal to minus a, so b is minus 3. Make sense? Okay. Anything else on the assignment?
Wait, so I like the corresponding equation equal to each other.
Yes. So if I know that this is equal to that, I know that my x squared term has to match my x squared term here. That just the x's has to match the 5 and so forth. Okay. Anything else? Okay, again, the way you get good at factoring is by doing a lot of factoring problems. So I have put an assignment out online for you. It is day 38, day 2 homework. And it's due tomorrow. And we have all these factoring problems, and then I have an answer key. So I want you to work all period on this and finish whatever you do not do, finish for homework, okay? Look for perfect square trinomials, look for difference of squares. Make sure you factor out a GCF if there is one. Always do that first, okay?